Hi, this is Aram Tabis, roll number 19EC01027. So, as the question was asked to do a statistical analysis of three sound signals, that is fan, train, and human speech signal. So, in analyzing fan sound signal, so first of all we have to create space of 1800 blocks for mean, kurtosis, and skewness to store the data of each second in the first 30 minutes. So for storing the data of first 30 minutes, we have run a for loop of for 1800 times. That is, we will analyze the data of first 30 minutes. For each second, we will store the data in one for loop. As we will go iterate one time, we will store the data of 1 second. So as we will iterate for the first time, for the sampling frequency 16,000, we will audio read the file for 1 second, and then we will store the value of mean in M, kurtosis in K, and skewness in S. Similarly, this process will go on for 1800 seconds and it will take the time and do it and store the value of mean, kurtosis, and skewness. Then we will calculate maximum of mean, kurtosis, and skewness, and also minimum of it, minimum of mean, minimum of kurtosis, and minimum skewness. These data we will analyze and copy it to where we will check the next half of the signal. Okay, after that the question was asked to do the analysis of train signal. So in analyzing train signal, we have taken again the same thing has happened here also. Okay, just the thing is we have changed the name of fan signal to train signal. Okay, we have created space for mean, kurtosis, and skewness of 1800 blocks, and then for 1800 times we have iterated, and then for sampling frequency 16,000, we have taken the data of 1 second each time and store the value of mean, kurtosis, and skewness, and then we have stored the value in maximum value of mean, minimum value of mean, maximum value of K, maximum value of kurtosis, minimum value of kurtosis, maximum value of skewness, minimum value of skewness. And then you have analyzed the human signal similarly, created the 1800 blocks for each, and then run the for loop 1800 times, stored the value of mean, kurtosis, skewness for the signal, and then we store the maximum value, minimum value of mean, kurtosis, and skewness respectively. And after that we went to check the last 30 minutes of each signal, of each signal. So we have stored the statistical analysis, whatever we will get here. Okay, in analyzing the data, we will just copy paste it, and we will check it. Okay, we will check. I will store the statistical data of all those signals. So first of all, we will store the we will check whether it is fan signal or not. So we have copy pasted the data, statistical data of fan signal. Then we created we created a variable f is equal to 0, and then we moved on from 1801 to 3600, that is from 1800 1 second to 3600 second of the audio file. Okay, we are storing, we are doing things there only. Okay, so we have stored the mean value for we have calculated the mean and stored it. We have calculated the value of kurtosis and stored it. We have calculated the value of skewness and stored it for 1 second, and we checked it whether it lies in that range or not, whether kurtosis lies in that range or not, whether skewness lies in that range or not. If it lies, then we are incrementing f. Okay, so similarly the process will go on for I think for certain time. Okay, we will get some value of f, and then similarly for train signal, we are storing the statistical data of the train. We have copy pasted the statistical data of train, and then we are again going from 1800 1 second to 3600 second, and we are going to check it. Okay, for sampling frequency 16,000, we are taking the value from 1800 1 second to 3600 second, and we are calculating mean, kurtosis, and skewness, and checking whether it is lying in that range whether kurtosis is lying in that range, whether skewness is lying in that range. If it is lying, then we are incrementing the train, we are incrementing the value of t. And similarly for human speech signal, we are storing the data of statistical data, and then we are just running the for loop from 1800 1 second to 3600 second, and just storing the value and checking it. First of all, we will check whether it is lying in the range or not. If it is lying, then we are incrementing. So we will create a vector of fth, and we will check out maximum of it, which one is maximum. If f is maximum and f by 18, this is basically percentage. F by 18 means percentage. Okay, where f by 1800 into 100 will be percentage, so that is f by 18. Okay, if it is greater than 90, that is accuracy is greater than 90%, then we are displaying the name simply fan.wave. And if it is not, then we will go here, we will check it. We will see whether train is maximum and it is having accuracy greater than this or not. So if it is, we will display train.wave signal. If if human signal is maximum and its accuracy is greater than 90%, then we will display human.wave. So in this we have audio read fan.wave, so we have got the value of fan.wave. We have displayed fan.wave. So thank you. This was Aram Tabis, roll number 19EC01027.